So you can very clearly see here that if I have the sine of pi over 6, pi over 6 is 1/2. So that means on my graph, I should be able to find pi over 6 on my angle down here. And then I should be able to say that that relates to 1/2. Now, we obviously don't have to get that specific because a graph is basically a sketch. Most of these are sketches. So we're going to look for the numbers that are really, really nice. So there are 4 numbers on the unit circle that are really nice for sine. Those 4 numbers are 0, 1, 0, and 1. Those are the 4 numbers. And they happen in 4 distinct locations. They happen at pi over 2, pi, 3 pi over 2, and 2 pi. So as we go around the unit circle, you can see around the unit circle that once we get here, we have a sine value of 1. Once we keep going, we have a sine value of 0, we have a sine value of -1, and we have a sine value of 0. So we can see that we have those angles there, all right? So what we're going to do when we graph this thing is we're going to graph exactly what we see. So here, I'm going to do this in red so you can see it. So here, I know that when my angle is 0, my sine value is 0. Angle of 0, sine value of 0. You can see that on your unit circle. Then I can see that when I get to pi over 2, I have a sine value of 1. So I'm going to go up to 1, and I'm going to put a dot here. And then I get to pi. And when I get to pi, that's just saying that it's at 0. And then I keep going, and I see 3 pi over 2. And that means, hang on, I'm going to change that a little bit. I'm going to put that one up here. And then I'm going to have that value at -1. So I can see that I have my, I can see that I have my points, and now all I have to do is just connect those points, and then it would continue on, right? So if I continue this on, I can keep going, and I would say, okay, when I get to 2 pi, at 2 pi, my point is 0. And then I could keep going, and I could say, because if we keep going around the circle, you can keep going, right? And you can very clearly see that we would then get to, so we have 4 pi over 2, then 5 pi over 2, then 6 pi over 2, then 7 pi over 2, and we just keep going around in the circle, and we keep repeating those points. So as we keep repeating those points, these are going to connect. That actually wasn't too bad. So these are going to connect, and then they're going to continue, because this is a cycle. It just keeps repeating over and over. So this value is going to keep going on and on forever. And it's going to go on forever in the other direction too, because we have negative values as well. So as we work our way through, we can see that we have created the sine graph. If you were to go to your calculator and write y equals sine of x, you're going to see this graph. Now, a couple important notes, a couple important things to think about. This area right here is really, really important because it is because it's the part that just keeps getting repeated. So no matter what happens, if we just keep repeating that over and over, if I copy and pasted this red part, I could paste it right here. And then I could paste it on again and again and again and again. And that's what creates this picture. Now that thing is called a period. So the red part is called a period. All right. So that thing is called a period. It's the part that is repeating. It is also what we can also call it one cycle. Oops. So we can also call it a cycle. And if you call it a cycle is just the thing that keeps getting repeated over and over to create the entire graph. So a period and a cycle are basically the same thing. It's the thing that keeps getting repeated over and over. Now, when we look at cosine, we can do the exact same thing that we just did with cosine. Because if I look at cosine, I can see on cosine, I can see on cosine that I still have x and y values around this graph, right? As I go up to, as I start at 0, when I'm at 0, my point is 1, right? So at 0, right here, I just go up to 1 and I would put a dot right here because the point 0, 1 exists. And then I continue on and I keep going and I see, okay, we'll look at pi over 2. Pi over 2 is the exact same thing as 0 for a cosine value. So when I get to pi over 2 is 0. And then as I keep going on, I see at pi, it's -1. Oops. So I'd have a dot at -1. And then as I continue on, I would see at 3 pi over 2, it would be 0 again. So 3 pi over 2 at 0. And then as we continue, we see when we get to 2 pi, 2 pi goes back up to 1. So at 2 pi, I'm back up to 1. So I can see what's happening here as well, and this would curve because it would again repeat the same way that sine repeated. And I would just keep repeating this over and over again. Now the same exact thing is happening because I'm just going to be repeating this same cycle over and over and over again and basically copy and pasting. Now if you look at this part, again, the blue part here is called a period. So this thing is called the period, or a cycle. So I can see that I still have a period or a cycle based on what this looks like, because it's the thing that keeps getting repeated over and over and over and over again. So since that thing keeps getting repeated over and over again, this part right here would just be copy and pasted over and over and over. All of those happen because of the relationship that the angle has with the sine value or with the cosine value. All right. So I'm going to just give you a couple of definitions and a couple of things that hopefully you can see and understand and kind of think about. But before we do that, we need to kind of think about what domains and ranges are. So if you look at this, for both of these functions, for both of these right here, if I look at my domain, I can plug in any number that I want, right? I can plug in any number for x. I can plug in all of the positive numbers and all of the negative numbers. So the domain for both of these is all reals. And the range for both of these is also the same, because when you look at the range goes from -1 to +1. So that tells me that my value is between -1 and +1. So -1 is less than or equal to y, which is less than or equal to 1. So all of these have the same domain and range. All of the x values can be plugged in, and only -1 to +1 can be outputted because of what that value is. Some of you also may have kind of realized that as you work your way through this, you would kind of realize that the cosine value and the sine, or the cosine graph and the sine graph, almost look identical to each other, except one of them is shifted one way. So like if I shifted sine left, it looks the exact same. That's because they have a relationship to each other. That's because x and y have a relationship, and that's something to kind of think of. Okay? Any questions that you guys can think of right now with what you're looking at? Hopefully that made sense on where I got my points. But now we're just going to do the same thing. If you remember way back to Algebra 2, remember in Algebra 2 when I gave you like a 6-page packet and I made you come up with what A is, what B is, what H is, what K is? I made you figure out all of those things. The same exact thing is going to happen right now. All right? So the first thing that we're going to talk about is the amplitude. So this is what we're going to be dealing with amplitude. Now amplitude is the height from the x-axis to a maximum, or the height from an x-axis to a minimum. So if I'm going to draw this for you, if I have a sine curve is going to look something like this. And I'm only going to stop it at 1 period. So right here, I'm just going to draw 1. You would know that this thing repeats forever and ever and ever, but I'm going to stop it right there. This thing right here would be called obviously a maximum. And this thing right here would obviously be called a minimum. Now with sine, the maximum and the minimum should be the same exact distance away from the x-axis. This height right here, from here to here, and also from here to here, is called the amplitude. So that thing is called the amplitude. All right. Now the amplitude is just given by the height from the x-axis to the top point, or the x-axis to the lowest point. And all of these are brought about by a vertical stretch or a vertical shrink. Because if you think about it, if you think about what's going on, the only way that I could ever change the highest point on this graph would be to stretch it, right? I could only change the highest point on the graph and the lowest point on the graph to stretch or shrink, right? So if I shrink it, it's obviously going to get lower, and if I stretch it, it's going to get a lot bigger. So that being said, the vertical stretch and the vertical shrink is still taken into account by either y equals a sine of x or y equals a cosine of x, the same exact way that it always has. And we can figure out what the vertical stretch or the vertical shrink is by taking the absolute value of a. This is the amplitude. So basically what's happening here is if I give you something that looks like this, where it's y equals -2 times the sine of x. If I give you something like this, obviously we take the absolute value of -2, which is +2, and this tells you that it is going to stretch both up and down by a factor of 2. So this is going to stretch by a factor of 2. That just means that I'm taking my graph and I'm stretching it by a factor of 2. So for the highest point used to be 1, now the highest point is going to be 2. The lowest point used to be -1, now the lowest point is going to be -2. So we're just stretching that either up or down depending on what direction we're going. Now that being said, we still have to pay attention to the fact that negatives exist. So if a is less than 0, that means that this is going to be a reflection. So I'm not adding anything new. I'm not adding anything that you don't already know. I'm talking to you about things that you should already remember. A still stretches and shrinks, and if it's negative, it flips it. If A is less than 1 but bigger than 0, it's going to shrink it, and if A is bigger than 1, it's going to stretch it. So that's just going to show you whether it stretches or shrinks based on what you're looking at. Okay, so let's look at an example of what this thing actually looks like, and we can see it put to the test. So I'm going to start by graphing my parent function. So remember, my parent function will use cosine for this. Nice job, Suki. So y equals, yes, you can. So it is y equals a times the cosine of x is our parent function. Actually, hang on. No, that's not a parent function. Y equals the cosine of x is our parent function. And let's say that our new function is like y equals -3 cosine of x. All of the directions in this are going to tell you to sketch it. That means it doesn't have to be perfect. It doesn't have to be beautiful. It's just got to be good enough to be able to tell exactly what's going on, which means that your labels are going to become the most important part of this entire thing. So I'm going to put this on a graph. I'm going to start with just my parent function. So I'm going to start here. Remember that my parent function, when x was equal to 0, actually, let me do this a little bit smaller. When the angle was equal to 0, my cosine value was 1. At pi over 2, and again, I can just look at this and it can tell me exactly what those are. At pi over 2, my angle was, or my y value, x value was 0. When we got to pi, it was -1. And then when we got back to the x-axis, it was going to be 0 again. And then when you get to 2 pi, it was going to go back up to 1. So I can see exactly where all of these points are. I don't know why I keep writing -1 right here. So I can see exactly what's happening. I can see my cosine graph. I can see that this thing, oh boy. What? Yes. My kids keep asking if they can have snacks. I just wish that they would just get them themselves. So then I've got my cosine graph. Good enough. Now this thing would obviously continue. So if you really, really wanted to, you could continue this on the other direction and you could keep going with this. But I'm only talking about the one part right now. So I can see right now that I'm talking about the red part, and I can get my comparison from that red part from this. So this is going to affect all of the y values. So my amplitude is in this figure is 1. My amplitude is 1 because the distance from the x-axis to there is 1. The distance from the x-axis to there is 1. So I can see what the distance from my x-axis is. Now, instead of it being at 1, it's going to go to 3. So now instead of my my distance being 1, now it's going to end up being 3. And it also means that it's going to be -3. So I can see that these things have flipped. But now the other thing that you have to pay attention to is I have flipped this thing over the x-axis. So that means that this point would have flipped down to here, but now it's going to be moved by a factor of 3. This point would have been flipped down here, but now it's going to be moved at a factor of 3. This point would move up here. So I'm just moving those points. And when I move those points, the only other thing that I have to really pay attention to is the fact that this point can't move and this point can't move, and I've still got my 5 dots that I can now connect my dots with. So now my cosine value is going to look like this, where I connect my dots. And you can see how it's now much, much steeper than it was before. and it would just keep repeating over and over. So if I'm comparing the blue part and the red part, you can see how it's flipped upside down and it has stretched pretty significantly. All right. So that's kind of what you're looking at. That's what that looks like. All right. So if you're looking at that, that's what you're kind of looking at. All right. So the other thing that I want to mention is you can find the amplitude. If you're not given the amplitude or you're not given anything, you're just given a graph or you're given, if you're just given a picture, then you can find your amplitude by taking the absolute value of whatever your maximum point is minus your minimum point and dividing it by 2. So the absolute, oops, I want to change the absolute value. So you can take your absolute value of maximum minus your minimum and divide it by 2. Okay, and I guess you could flip it the other way too. But on that last question, our maximum value is 3. Our minimum value is -3 over 2. So that tells me that my absolute value of 6 over 2, and that is 3. You could also just look at this and count from the x-axis up. And if you count from the x-axis up, that's pretty much it. All right. So tomorrow we'll probably get into horizontal stretches and horizontal strengths. And then we'll talk about also shifting the graph left or right or moving it up or down. But as you look, this is just the same exact stuff that we've been talking about over and over, except now we're adding on a little bit of trig with it. So we're taking the exact same values, the exact same stuff that we've already taken, always done, and we're just adding a few more things to it. All right.